Hey everybody, welcome back. This is Calculus 3 at Colleges of the Sequoias. It's Math 67, and this is the fall semester of 2022. We are continuing our study of parametric equations of lines. This is 11.5 in Anton. And so let's jump right into it and take a look at this problem we got going on here. Let's say we have a line L, and I drew a picture. And we can write it, let's write it in terms of like parametric lines, parametric equations. So I've got L as a function of a starting vector plus t times a vector going from there. So if I write L in terms of its parametric equations, x of t is 5 plus 2t, y of t is -1 plus 3t, and z of t equals 1 minus t. So let's say we have that line and we have another point P naught that's off the line. And we want to find the line containing P naught that is perpendicular to L. So that's what I drew here. Now the picture helps that I already drew a point Q. But without the point Q, you might want to stop and think about it. Okay, it crosses somewhere. Where is it crossing? Well, let's just call that point Q. So since Q is on L, it's on the line, we can write it in terms of the parametric equations. I could say x of Q, y of Q, and z of Q is some variation of this. We just don't know what the t value is. Okay. So that's what we're going to work with. We want to take a look. Okay, what we need right now, we're going from P naught to Q. Maybe let's vectorize this. Let's see what's going on there. So P of Q is going to be Q minus P. Remember, our Q components minus our P components. So x of Q minus 0, y of Q minus 4, and z of Q minus -8. When we write those out, this is what P of Q looks like. Okay. The velocity component of something, or the v component going, or the line that's parallel for it like this is 2, 3, -1. And so if we want to show orthogonality, we learned how to do that here in this class. Dot product, baby. So let's do the dot product. PQ times V. So I've got 2 times the, I'm just dotting the two things. 2 times the x part is 2xq. I've got my y component of B times the y component of PQ. 3 times yq minus 4. And our z components multiply -1 times zq plus 8. We know the dot product should equal 0, so I set it equal to 0. Okay. Then go ahead and we'll clean up the line a little bit, combining like terms. I distributed. So we have 3yq minus 12. And minus zq minus 8. The -12 and the -8 become -20. And I can add these two to the other side and I get 20 on the other side. And we're left with 2xq, 3yq, and -zq. We're left with that equation right here. So what is that? What can we do with it? Well, I have it written on the screen, 7. This is where writing ahead of time doesn't always work well. We're going to sub in our line L that we had up above. Just to bring it back up for you, 5, -1, 1, and then t times 2, 3, and -1. Or these components right here. So I'm going to replace x of q with 5 plus 2t, y of t with -1 plus 3t, and z of q with 1 minus t. I did that here. And now, rather than having three different variables, X, Y, and Z, we have one variable in terms of time. That's why we like these parametric equations. We can get it down to one variable, time. So let's solve here. Distribute. 2 times 5 is 10. 2 times 2t is 4t. 3 times -1 is -3. 3 times 3t is 9t. And then we distribute the negative sign, -1 and positive t. If we combine like terms, we get 14t plus 6 equals 20. So solving there, subtract 6 from both sides and divide by 14. T equals 1. Okay, so what can we do with that? Well, we can figure out what Q is, right? We've got equations for line Q right up here. So I'm going to plug in T equals 1 right here. I'm just adding the components. 5 plus 2 is going to give me 7. -1 plus 3 is going to give me 2. And 1 minus 1 is going to give me 0. So Q is at the point 720. Okay. And I'll do the next part on the next page. So those are our 2 points now. We've got 0, 4, and -8 for P, and then Q is 7, 2, and 0. We know the vector for the line L is 2, 3, -1. That line is parallel to that vector. So what can we do here? Well, we can figure out what the line is from P to Q now that we got the 2 points. So we've got 7. Remember, we subtract starting point from end point. So 7 minus 0, 2 minus 4, and 0 minus -8. That PQ vector becomes 7, -2, and 8. Just to make sure I'm accurate, I'm going to go ahead and dot that with the V vector and make sure I get 0. It should be 0, so they're orthogonal or perpendicular. So let's dot that real quick. I've got 7, -2, and 8 dotted with 2, 3, and 1. 7 times 2 is 14. -2 times 3 is 6. And 8 times -1 is -8. That must have been a spam caller because I don't recognize the area code. 14 minus 6 and -8 does equal 0. They are orthogonal, so PQ is a vector perpendicular to that line L. Now we just need to write it in terms of L. We can figure out the distance real quick if we wanted to. The distance from P to that line, the minimum distance. We take PQ and find the norm of it. So 7 squared and -2 squared and 8 squared gives us 49, 4, and 64. We add it up, we get 117. The square root of 117 is about 10.8. So the distance from point P to the line, or the point Q on the line L, is about 10.8 units. Okay. So we want to write the line perpendicular to L. We're going to use that vector. We now have a vector and the starting point. So we can do PT equals P naught plus TV. This is going to be our V now for that line. And P will be, that will be our P naught. So let's do that. Remember, we're multiplying T times everything in our V vector. So 0 plus 7T 4 minus 2t and negative 8 plus 8t. So that's that line written in terms of parametric equations for it. So we found it. We even found the distance. There's another cool way to find the distance other than going through all that. It involves a little trig. That we're wrapping up this 11.5. I thought I'd show it to you. We're going to draw a triangle. So our point P is over here, Q is over here, and we're going to say it just makes some angle. And we'll use the 5, -1, -1 as one of the starting points. That was from our initial line L. Where is it? L had 5, -1, 1. We're going to use that as our starting point. So we're looking for that distance D there. We already calculated it is about 10.8. I could make a vector from there to Q and there to U, or there to P, call that U. So that forms an angle theta. And so sine theta is opposite over adjacent. It's D over the magnitude of U. So what can we do with that? D equals, we solve for D. D is the magnitude of U times sine theta. I'm going to throw in, this is just to do some fun stuff. Check this out. I'm going to multiply that by V, magnitude of V over V. It doesn't change the value. But hopefully you guys see where this is going. Remember, magnitude of U, magnitude of V times sine theta is the magnitude of the cross product. So I've taken this top part and written it as the cross product over the magnitude of V. Okay. So we need U and we need V to do this. So U, we're going to go, we know the point for P and we know our point over here. So we'll go from P to, or I'm effectively going from here to here. It doesn't matter which way we go. I've got 5 minus 0. I've got 4 minus -1. I've got -8 minus 1. This gives me a U vector going that direction of -5, 5, and 9. We already know B. B was this 2, 3, and 1. So let's do the cross product. I kind of sped it up a little bit. I didn't show all the steps of the cross product. You should get, when you do it, 5 times -1 is -5 minus 27. Might have got the wrong damn value. Did I get the wrong damn value? -5 minus 27. Looks like I screwed it up. That's funny because I get the right value at the end. Pause this for a second. I figured out my error. -8 minus 1 is -9 right here. So that makes this a -9. So -5 minus -27 means plus 27. 27 minus 5 is 22. Then we do the J component. It's going to be the negative value, whatever we get. I've got 5 minus -18. So 5 plus 18 is 23, but it's the J component. So it gives me -23. And then we do the K component. -15 minus 10 is -25. When we take the magnitude of that vector, we get square root of 16 over 38. V had a magnitude of 14. square root of 14, I should say. And so when we do D, we plug those values into D. Square root of 16 over 38 over 14 gives us square root of 117, which is, again, approximately that 10.8. That'll wrap up 11.5. Thanks for your time. Sorry about any confusion. Hopefully I'm back on my A game soon. Peace.